Okay, so today we need to talk about simplifying square roots. These are just going to be basic square roots, but you use them for a lot of other things. So like in the upcoming weeks, we're going to talk about adding and subtracting them and multiplying and dividing them, but it all starts with simplifying. So if you have the square root of 45, what we do is we do something called upside down division to simplify them. So you take whatever number's here, and it goes in this little half box thing. And then what you have to do is you have to come up with prime numbers that go into 45. Prime numbers are numbers that can only be divided by 1 and themselves. So we're talking like 2, 3, 5, 7. But like 4 is out because it divides by 2. 6 is out because it divides by both 2 and 3. So that's where you start. So prime number that goes into 45 would be 5. So then what you do is you do 45 divided by 5, which is going to be 9, and that goes here. Now you're going to repeat the process. So you need a prime number that goes into 9, which is 3. So then you do 9 divided by 3, which is 3. Then you need a prime number that goes into 3. Well, 3 is a prime number, so 3 goes into that. 3 divided by 3 is 1, and once you get to 1, you stop. So to simplify square roots, some numbers get to come out of the square root and other numbers get to stay inside the square root. The way that you figure out what numbers get to come outside the square root is you look for pairs. So here you have 2 3s, which means you have a pair of 3s. So because of that, 1 3 gets to be outside the square root. And then the 5 that has no pairs stays inside the square root. If you have multiple pairs, say I had a 3 and I had 2 2s, then you would pull them both out and multiply them together. Similarly, if you had multiple numbers that had no pairs, you would multiply those together as well. Okay? So now we're going to do the other 5 problems that are on your notes and probably talk about a couple other things that aren't written down, but I want to make sure we cover them. So I'm going to move across, not down. So next one's going to be the square root of 48. So same deal. 48 goes in that box, and you need prime numbers that go into 48. So prime number that goes into 48 is 2. 3 also goes into 48. You could have started with that. It doesn't matter the order that you come up with these outside numbers. Your inside numbers might change, but no one cares because you're only looking at the outside numbers. So you're going to have the same outside numbers regardless of order. So 48 divided by 2 is going to be 24. 2 goes into 24. 24 divided by 2 is 12. 2 goes into 12. 12 divided by 2 is 6. 2 goes into 6. 6 divided by 2 is 3, which is prime, and you have 1. So you've got a pair of 2s and then another pair of 2s. You're going to plot a 2, a second 2, and then this, which has no pairs, is going to stay inside. And then you got to multiply those together, and you have 4 square root of 3. Next one is the square root of 108. Fine, so same deal. You put 108 in the box. 2 goes in. 108 divided by 2 is going to be 54. 2 goes in. 54 divided by 2 is 27. 3 goes in. 27 divided by 3 is 9. 3 goes in. 9 divided by 3 is 3. 3 goes in. 1 pops out. So you got 2 2s, 2 3s, and the sad little 3 left over. So you're pulling a 2 and a 3. That one stays, so then you're looking at 6 square root 3. Next one. 50. Same thing, goes in the box. So prime numbers that go into 50. 2, you get 25. 5, you get 5. 5, you get 1. 5 pulls out. 2 stays in, and that's your answer. next one is the square root of 180. So, goes in the box. 2 for the umpteenth time, you get 90. 2, you get 45. 5, you get 9. 3, 3, 3, 1. So you'll pull a 2, you'll pull a 3, left over. So you have 2 times 3 square root 5, which is 6 square root 5. All right, so last one is 270. So same deal, goes in the box. 2. You get 135. 5, since there's a 5 or a 0 at the end. You get 27. 3, 9, 3, 3, 3, 1. So you got a pair of 3, so you'll pull a 3. Inside, you have a 2, a 5, and a 3, all of which have no pairs. So all of them stay inside. And you'd multiply them together. So you're doing 2 times 5 times 3, so then you end up with 3 square root 30, which is fine, okay? So a couple other things I want to talk about that aren't in the notes, but I want to cover it so people don't get confused. Let's say we have the square root of 6, and we're trying to break the square root of 6. When you try to break 6, notice you have pairs of nothing. If you have no pairs at all, it just stays the square root of 6, and that's as simplified as it could possibly be, okay? Similarly, let's say we had the square root of 9. Okay, now in theory, you know the square root of 9 is 3, but let's pretend it was a larger number than 9, okay? And you didn't know what the square root was, or you don't know the square root of 9 is 3. Fine. You can still take it and put it in the box. Break it down the way that we broke all the other ones down, and what you'll notice is that all you have is pairs. So if all you have is pairs, that'll come out, and you'd have nothing left on the inside, which is fine, okay? So those are your notes on simplifying square roots.